of a salt to be acidic, neutral, or basic. Any question on that? And I also believe you are given molecular equation. There are rules you follow if you are to name organic compound. I believe you still remember how to identify the homologous series to which a particular compound belongs. Yes. Now, what is homologous series? What is functional group? What is functional group? What is functional group? What is functional group? Yes? That's it.
Functional group is an atom common to the members of the homologous series, which determines the chemical properties of the series.
Please clap for him. Functional group would be bond or group of atoms, and this is common to a particular homologous series and it determines the chemical properties of the series. So if you know the functional group, you will know the homologous series to which a particular compound belongs, and it's where you can name the organic compound. For example, if an hydrocarbon contains carbon to carbon single bond, such an hydrocarbon is referred to as alkane. If we have carbon to carbon double bond between hydrocarbon, we say the hydrocarbon is what? Alkane. So if we have the carbon to carbon triple bond between the hydrocarbon, is referred to as what? Alkyne. If you have OH attached to the group, it becomes what? Alkanol. So that means all alkanols will contain carbon, hydrogen, and OH. Because this will help us if we want to name the organic compound. So we have a carbon, so now you have this one this way, or it is written as COOH. This is the functional group of alkanoic acid. So if you have the carbonyl group and there is hydrogen attached to it, this is referred to as alkanal. But if the carbonyl group has no hydrogen attached to it, it is referred to as alkanol. So if you can identify the functional group, it will be easier for us to name the organic compound. So we have, this is referred to as alkaloids. And these are the ones we are going to name today. Now, if you have identified the functional group present in the organic compound, from there you should be able to know maybe the compound you want to name is alkane, it is alkene, it is alkyne, alkanol, alkana, alkanol, alkanoic acid, or alkanol. Then how do we now name the compound? The first thing in naming organic compound is to identify the longest continuous carbon chain, which must include the carbon that carries the functional group. Please, that one is very important. You identify the longest continuous carbon chain. Identify the longest carbon chain, which must include the carbon that carries the functional group. So the carbon that has the functional group must be counted above the longest chain you want to count. Once that is done, you number the longest chain, which we call the parent chain. That longest chain that you have identified is called the parent chain. Then what we do now, number the parent chain. Starting from the side that gives the lowest number to carbon with a functional group. That means when you want to number the parent chain, you must consider the side that will give the lowest number to the carbon that has the functional group. Are we together? If you start from the right, if the number of carbon that carry the functional group is 10, and if you start at the left, if it is 2, it is important for you to start from the left. So your numbering should start from the side that will give the lowest number to the carbon that carry the functional group. Are we together? Name the substituent. So what we call substituents are alkyl group or halogen. Now when you say substituent, what is attached to the parent chain that is not hydrogen is referred to as the substituent, and it is usually alkyl group or halogen. Can you give an example of alkyl group? Methyl, ethyl, propane, and so on and so forth. So when you have methyl or propane or ethyl attached to the parent chain, that could be called a substituent. Or you have either chlorine or fluorine or bromine attached to the parent chain. We refer to it as what? Substituent. So name the substituents in alphabetical order. That means if we have different substituents, for example, we have bromine and we have chlorine. That means you mention or you name bromine before chlorine. Or we have methyl, we have chlorine. You should name chlorine before methyl. So, name the substituent that is alkyl or halogen in alphabetical order. If the substituents, if you have two different substituents, if two substituents that are the same is attached, use, there's if two or more substituents that are same is attached, use the previous two for that. That means we have two substituents that are the same. You are going to tell us the number to which the substituent is attached to and use the previous that. If there are three, you write the number to which those three substituents are attached to and use the previous try. And if there are four, you mention the carbon number to which each of the substituents is attached to, then use the previous tetra. So use 2 for die, 3 or try for 3, and tetra for 4. that you must follow. Yes, let's move on. There should be comma between numbers. Let's say you have numerator attached to column number 2 and column number 3. You must write 2, 3. If there is no comma there, you just write 2, 3. What have you written? 23. Before you now put that. So you use comma between numbers and use hyphen between numbers and alphabets. Let us do that. Use comma to separate numbers and the hyphen between number and alphabet. And you should know that when you write the name, it is one word. You don't separate it. Not that you write 2 meti, 2, 3 dimeti, you now write meti separately. You will not get to. You don't leave space between the name. Are we together? It's like you want to write acid. You now write A here, you now write seed. The space, you have less space to apply raw gas are there. So you want to provide the space there so that the examiner will have cross between there. It's one word. Now let's look at an example now. Or do you have any question on what I've just explained on the steps? These are the steps you follow if you want to name any organic compound. Any questions on the steps before we now use the step to name compound? Feel free. There's no question. Now let's also look at one example. Let's look at an example. The functional group is very important in writing the name. Because the functional group that will tell you the compound we want to name is alkane, or it is alkane, or it is alkyne, or it is alkanol, or alkanoic acid. Are we together?
Yes.
Now let us clean this. So let's also look at this. What is the name of this structure? If we look at it from what is given, this compound belongs to which homologous base? Alkane. You expect what you are going to name is going to be what? Either in or pentane, propane, or anything in, because it is an alkane. And we can say that this compound is an alkane because we have carbon to carbon single bond, and it's all hydrocarbon. Now, if you go by the rule, we identify the longest shape. Look at the counting: 1, 2, 3, 4, 5. Or you can count 1, 2, 3, 4. Or you can count 1, 2, 3, 4, 5, 6. So the longest chain is 6. That means this compound will be what? XZ. But if you want to assign number to the carbon atom here, is that we'll start the numbering here or we'll start the numbering here? But do we have a something attached to this carbon? Let us look at the period shape. This is period shape. You can see the carbon that is highlighted here. Each one of it is having an hydrogen attached to it, with the exception of this. This carbon is having this. This is not hydrogen. So this is referred to as a substituent. So the numbering we want to do must start from the side that will give this carbon the least or the lowest number. If I start counting it, 1, 2, 3, 4. We started from this 1, 2, 3. You know, you start here, it gives this carbon the least number. So it is compulsory for you to start numbering from here. So we have 1, 2, 3. This number that we are writing here is referred to as locant. The number is called what? The number is referred to as what? So it helps us to locate the substituent or the functional group. Where do we have the substituent located? Here. At carbon number 3. So the name will be 3-methyl. So that 3-methyl is attached to carbon number 3. And the longest chain is what? 6. And this compound is what? Alkane. What is the name of 6 carbon atom in alkane? So that is 3-methyl. You see? There should be hyphen. These are the rules you have to follow. If you don't put the hyphen between the figure and the letter, Ojoyo, and you should not leave space. This is one word. So 3-methyl hexane. It is very simple to name organic compound, or is it not simple? So let's look at this one. Want to name this compound. Let us identify the longest chain here. And count this way. We have a 1, 2, 3, 4, 5. But you see, the question says is it proper for us to name count like this? 1, 2, 3, 4, 5. Why? Because the functional group is not inclusive. The scriptures they identify the longest carbon chain, which must include the carbon that carries the functional group. There is presence of functional group here, which is what? The double bond. So if we want to identify the longest carbon chain, these two carbon atoms must be counted. So is that we count 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5. Do you see it? 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, or 1, 2, 3, 4. In each of the counting, the double bond is inclusive. Now, which one is the longest from the counting? 6. So now, if you want to count down, want to number this carbon atom, we must give reference to the carbon that has the functional group. Where do you have the functional group? Where do you have the functional group? You can see that this is now 1, 2, 3, 4, 5, 6. Is that? 1, 2, 3, 4, 5. So that is the longest. You can say there is a substituent here. That is one substituent. This also has a substituent. Now, if you want to start numbering here, your numbering should start from the side that will give the lowest number to the carbon that has the functional group. Is that okay? You must consider the carbon atom that carries the functional group. Let us do the numbering from both sides. If you start from the left, we have 1, 2, 3, 4. It will follow carbon number. Remember, this functional group is shared between this carbon and this carbon. If you start from the right, from the left, it is this carbon that has the functional group. If you are starting from the right, it is this carbon. So if you account from the left now, I have 1, 2, 3, 4. The functional group will be on carbon number 4. If you start from the right, 1, 2, it's first on carbon number 2. So that means our numbering should start from the right. So we have 1, 2, 3, 4, 5, 6. That means we have methyl group attached to carbon number 3. And we have another one attached to carbon number 4. Then the functional group is attached to carbon number 2. Do you understand? The functional group is attached to carbon number 2. But the first methyl group is attached to carbon number 3. And the second one attached to carbon number 4. So now it means we have methyl group. One attached to carbon number and the second one attached to carbon number 4. You are not responding. Are you tired? So that means we have 3, 4. Because we have two substituents that are the same, we use the previous di. So that is dimethyl. Then we have X2N. X2N means the functional group, which is alkane, is attached to carbon number 2. And as carbon number 3 and 4, they are methyl group. Then the longest chain is 6, and that is why you have what? Hexane. Instead of writing it like this, it could be written like this: 3,4 dimethyl 2-hexane. Remember, there should be even between the figure and the alphabet. If you don't put it there, that means you don't follow the rule, it will be marked wrong for you. And you should not leave space. It is one word. Any questions so far? You are getting it small, or big. Or you have gotten it all. I should give you your own, or I should still give you more. Once more. I should give you your own. No, let's do 2 more examples. Let us identify the longest carbon chain. So the only way to count this is to count the horizontal carbon chain. There is no other way. Because that's the only way you can count. But you can say 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. Do you see as I've counted it? 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. So the longest chain is what? 7. Now, if you count from the left, remember the functional group is between this carbon and this carbon. If you count from the left, the functional group will be on carbon number 6. Let's count. 1, 2, 3, 4. If you count from the right, The first round will be Okamo 1, 2, 3. That means it is compulsory for us to start the counting from the right. So we have 1, 2, 3, 4, 5, 6, 7. Now, where do we have the substituent attached to? We have 1 attached to number 2. We have 2 attached to carbon number 5. But the number has to be in, the substituent must be named in alphabetical order. What are the substituents present there? Dominant. Then which one come first? So that means we have 5, 5. Dibromo. Then we have 2 methyl. That is what? What? 3 times. Or you can say 3 times. It's very simple to name organic compound. You may be given the structure in condensed form. You know all the one given to you now, you have the structural formula where all the bonds were shown. You can see how the carbon atom is bonded to all other atoms. But you will be given in such a way that everything will be condensed together. For example, you may be asked to name the compound like this: CH3, CH2, CHCl, CH3, CH2, CH2. Can say that the one we are given here, the bond is not shown. The bond is not shown. Then how do we name this? How do we name this? Whatever that is given in bracket shown is a substituent. Any carbon present in the bracket is a substituent. And of course, where you don't have hydrogen attached to it, it's going to be a substituent. Is that a substituent here? No. Do we have here? No. Do we have here? Yes. You can see, you can see this carbon has hydrogen and chlorine. Chlorine is going to be a substituent. If you come to this place, you can see this one is given in bracket. It shows that this CH3 is a substituent that's attached to this carbon. Then you look at this one, and the 3 here. Now, what will be the longest chain here? 1, 2, 3, 4, 5, 6. You see, I did not count the one in bracket because this one shows that it is a substituent attached to the previous carbon atom. Is that okay? So the longest chain is 1, 2, 3, 4, 5, 6. Let us name like this. What's like 1, 2, 3, 4, 5, 6. Let us look at if the numbering is from the left. Where do you have the substituent attached to? Which carbon atom do you have? You can see we have one attached to carbon number 3, another one attached to carbon number 4. That's it now. But if you start the numbering from the right, will give us 1, 2, 3, 4, 5, 6. That will be which one and which one? 3 and 4. 3 and 4 in both sides. So that means you can start the numbering anywhere since you are going to have. But look at it. It will be very difficult for us to see. If you consider this one, chlorine is going to be named first, followed by methyl. But Okay, let's look. I will teach you something here because this one, when you even good, I have something like this. The emphasis on name of compound is to know the lowest number. Remember, there are two subjects attached to carbon number 3 here, or carbon number 4 as the case may be. So it will be wrong for us to start numbering from here, from the right, from the left. It's back where you look at this. You can start 1, 2, 3. By the way, this will go to give us 6, and this will give us 4. Make it what? 10. If the number is from this, we are going to have 3 here, and what we are going to have here? 4, 4. That's going to be what? 11. Between 11 and 10, which one is the lowest? It's the least. So it means it's better for us to start from the right. So that means the thing is going to be 4 fluoro, because you have only attached to carbon number 4. How many methyl do you have attached to carbon number 3? That is 3,3 dimethyl. The longest chain is what? 6. That is hexane. So the name is 4-fluoro-3,3-dimethyl hexane. Do you understand what I'm explaining here? Or you don't understand? What I'm saying is this. Look at the way I've numbered it. If I start numbering here, carbon number 1, 2, 3, 4, 5. There is 2 here. This is 5. This is 6 carbon atom. If I want to look at where the substituents are attached to, I have chlorine is a substituent attached to it. That's carbon number 3. This is methyl attached to it. That is over 3 and 4. Are we together?
Yes, sir.
That means we only have something attached to carbon number 2 and carbon number 3 and carbon number 4. If I also start from the right, 1, 2, 3, 4. I also have the subject attached to carbon number 3 and carbon number 4. And I say it will be wrong for you to start from the left. Because let us start from the left. Maybe if I measure if I get. You have said that if you start from both sides, the subject will be on carbon number 3 and carbon number 4, right? Either we start from the left or start from the right. The subject fall on carbon number 3 and 4. Then I will look at the one that is going to be the right answer. I've named the compound if the substituent, if the counting start from the right. Let us name it if we start from the left. Now, what will be the name if you start from the left? This is going to be 3 fluoro. Then we have 4,4 dimethyl what? Hexane. If I count the number here, this is 4 plus 3 plus 3 to give us what? 10. But if I count this one, this is 3 plus 4 plus 4. That is what? 11. Which one is the lower number? So this means this is right and this is wrong. Do you now understand? But if we are to be there is presence of functional group will state that we will give preference to the one that carries the functional group, that list number. There is no way you start from both sides that will do the same number. And that's okay. But when you see alkane like this, if you start from both sides, if it's giving the same number, name the compound and count. The one that have the lowest will be the right one. Let's look at the final one before I give you the one we do. So let us look at this. CHOH, CH3, CH2, CH3. This compound belongs to which homologous race? Alkanon. Do you all agree with that? Why does it belong to alkanon? Presence of OH. Automatically, your numbering should start from the side that will give the least number to this carbon atom. There's no controversy. Here we're able to look at this on both sides because what you have here is carbon to carbon single bond. But here, the functional group is here, so there is no controversy. So you have carbon number 1, carbon number 2, this is carbon number 3, carbon number 4, and carbon number 5. The functional groups of carbon number 2. Then we have methyl group attached to carbon number 3. This goes to what? 3 methyl. This is pentanol. Abi? Can you respond? Yes. 5 carbon atom. That is what? Pentanol. But where do we have the OH attached to? That is going to be pentan 2 or 3 methyl 2 pentanol. So 3 methyl pentan 2 or 3 methyl 2 pentanol. Any question on this? No question? Now, write the name of the following compound. Write the name of writing it. Yes, what's the name of the compound? Three, 6 hexanol. 3 methyl 6 hexanoid. Yes. 3 methyl 1 hexanoid. Yes. Who else? That girl from which days? 3 methyl hexanoic acid. Yes. Who else? That is very. Now, where the first 3 students that named the compound made mistakes these days, you don't need to tell us the position of functional group in an alkanoic acid. The functional group is always at the terminal carbon. Hence the name and the position is not needed mentioned. If you look at this is the first carbon, right? Carbon number 1, 2, 3, 4, 5, 6. That makes it to be hexanoic acid. But at carbon number 3, there is methyl group. You don't need to tell us hexanone oil. No. The carboxylic acid is always at the terminal. You cannot start the numbering here. This functional group is always at the first carbon atom. So it is not necessary for you to tell us 1 oic. No. So the name of the compound is 3 hexanoic 3 methyl hexanoic acid. Is that again? The same thing is applicable to alkana. Alkana functional group is always at the first carbon atom. Hence, you don't need to tell us 1 or 3 methyl 1 and no. Because it's like you say, okay, I'll give you an example, I'll give you a question like that. Try this. Now the second compound, what's the name? 4-methyl We have carbon number 1, 2, 3, 4, 5, 6. The 2 functional group is on carbon number 4, and that is bromine and methyl. So what we have is 3 bromo, 4 methyl, so 4 bromo, 4 methyl, then what? X what? 2 A. So it's 4 bromo, 4 methyl, X2A. Or you can write it as 4 bromo, 4 methyl, 2 XA. Number 3. You can see there are 2 functional groups here, and that is alkane. Carbon number 1, 2, 3, 4, 5, 6. Then there will be what? 2 bromo. What? X 2 4 diene. Because there are 2 alkene functional groups attached to this carbon. One is attached to carbon number 2. The second one attached to carbon number 4. That means what? 2. That means there are 2 alkene functional groups. One attached to carbon number 2. The second one attached to carbon number 2. And use the previous die. If there are 3, you write what? Tri. If this is 1, 2, 3, it's going to be what? Triene. when we have 2,3-dimethyl, then the next one, what's the name? 2-iodo-4,4-dimethyl. So you can see this is carbon number 1. Carbon number 2 have iodine attached to it. This is carbon number 3. Then carbon number 5 has 2 methyl group. Then you have 5, 6. So it's going to be, which one comes before iodine and methyl? I before N. That is going to be 2-iodo. That is what you have for 4,4-dimethyl. Dimethyl what? Hexane. 2-iodo 4,4-dimethyl hexane. The last one, what's the name? 2,2-dimethyl propane. You can see that this carbon has 4 methyl attached to it. You can write it as this: 1 methyl to the left, 1 methyl to the right, 1 methyl up, 1 methyl down. 4 methyl group attached to 1 carbon atom. This is the carbon atom. 1 methyl to the right, 1 methyl to the left, 1 methyl up, 1 methyl down. Then you can name like this: carbon number 1, carbon number 2, carbon number 3. Carbon number 2 has 2 methyl group attached to it. So that is 2,2-dimethyl, but there are 3 carbon atoms. Okay. So the name of the compound is 2,2-dimethyl. Okay. Any questions? Any questions? Yes, no question. Let me give you another one. You can say the functional group alkana as the first carbon atom. So an alkana functional group is always as the terminal carbon, just like alkanoic acid. So it is 2 what? So the position of the functional group here needs not to be mentioned. Then the second one, you can say this is an alkano, and you have the functional group at the second. You can say this is pan 2 4, or you can just say butanol, because the functional group cannot move between, only move between this and this. If you start from here, it's buta 2. If you start from here, it's also buta 2 1. I go together. You can simply say butanol. Then this will be what? There is a mistake here. This was supposed to have 0 to this. So it should be C double bond to oxygen, and this is the functional group of an alkaloid. Then what will be the name? That is methyl. Then we have 1, 2, 3, 4. That is butanoid. Methyl. That is alkyl. Then you have the alkaloid. In naming an alkaloid, you mention the alkyl at the right hand side, then followed by the alkaloid. So it is methyl what? Butanoid. Methyl butanoid. Methyl butanoid. Now this is also an alkaloid. This one becomes what? This is the alkyl group, which is C3H7, and that is propene. Propene what? This is 1, 2 ethanol. Propane ethanol. Then this is alkaloid. It is an organic compound with multiple functional groups. You can say we have OA, we have alkaloic acid. When we have functional group like this, the alkaloic acid would be the priority functional group. So automatically this will be an alkaloic compound. And this is going to be a secondary functional group. And it will act as a substituent. So that's going to be what? 3 hydroxyl what? Butanoic acid. This is 3-hydroxyl butanoic acid. You know you have alkyl functional group, you also have alkyl functional group. But between the alkyl and alkylic acid, the alkylic functional acid will be the priority functional group. And that group will be primary. And this will serve as secondary functional group. So it serves as the substitute. Now before we call it a day, write the possible isomers of pentene. The possible isomers of pentene and its alipag and its name. Write the possible isomers of pentene and write the name of each isomer. The possible isomers of pentene and the name of the structures. So write the names and structures of pentene. Write the name and structure, name and the structure of isomers. Isomers of pentene. C5H10. Alkene has the molecular formula CnH2n. Pentane is the compound with 5 carbon atoms. So it goes to C5H10. So the best way to look at this is to write the, first of all, write all the 5 carbon atoms straight, and then you can put the double bond in the first carbon atom. And you can now complete all the hydrogen with the carbon. So make sure the carbon, each of the carbon is having 4 bonds attached to it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we have C5H10. You see this already have 1, 2, 3, 4. You cannot have hydrogen here. This already have 1, 2. You only have 2 bonds attached to it. So this is pentene. Is that okay? Instead of having the bond attached to carbon number 1, you can write it as carbon number 2. So that is you have 1, 2, 3, 4, 5. Then you take the double bond on carbon atom. We have 1, 2, 3, 4. We have 4. We have 4. We have 4. 2, 3, 4. We have hydrogen, 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 hydrogen. That is 1 here, 1 here, 1 here, 1 here. You count the hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But in this case now, the double bond is now attached to carbon number 2. So we call it what? Pent 2 in. That means pent 1 in and pent 2 in are isomers of pentane. What type of isomer are they? They are positional. They have the same arrangement of carbon atom and hydrogen, but they only divide the position of their double bond. They are referred to as positional isomers. Now, can the double bond come to this place? Because if you come to this place, instead of starting from the right, you are going to start from the, and that's still going to be pent 2. Can it come to this place? It's still same as what? Pent 1. So that means that is only one we can have. Now we can now write the 1 carbon atom like this. Then you take 1 carbon as branch. Then the first carbon here can have the double bond. Then complete the remaining one. Already this carbon has already 4 bonds. You cannot have anything attached to this. You can have 1, 2, 1, 2, 3, 1, 2, 3. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a C5H10. But the name of this compound now becomes what? This is carbon number 1, carbon number 2, 3, 4. This is what? 2 methyl, put 1 in. Is that? Can we take the double bond here? Can we? So let's look at this. 1, 2, 3, 4. They have this one. They have it. 1, 2, 3, 4. They have 1, 2, 3, 4, 5, 6, 7, 8, 9. They have 10. Then we say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is C5H10. And this one will be what? Carbon number 1, carbon number 2, carbon number 3, carbon number 4. Now we have 2 methyl. What? Goes 2 in. Can the carbon come to this place? Because if it comes to this place, it's still be as what you have here. Will it? Yes. If I write it here, if I start the counting here, 1, 2, 3. To be another compound now. Look at what I'm saying. Let's look at it. If the name is the same, then we have the double bond here. 1, 2, 3. Then you have this one. 1, 2, 3, 4, 5. Let's try it. If you give us the same name, then it means it's not possible. This is 1, 2. This is 1, 2, 3, 4. This is 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. Will it go that way? Will it? Let's look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What will be the name of this compound? This is carbon number 1, carbon number 2, carbon number 3, carbon number 4. That will be 1, 3 methyl, put 1 in. Have you written something like that? Let me just answer super. Once you write the name, if the name is not totally with any other, it means it's another isomer. So this is going to be 3 methyl what? Put 1 in. Can we have another structure? Yes. We can have it. So try the remaining isomer for this. Then now write all the isomers of hexane as an assignment. Till we meet again for another chemistry class, enjoy the rest of the day.